optimization across a set of Google Kubernetes Engine or GKE in short clusters can include a handful of areas to think about. And this isn't a one time task. Instead, it's a continuous journey that cluster administrators, workload owners, and even billing managers all take part in. GKE has numerous features built in that you, as a cluster administrator, can use to navigate this continuous journey of optimizing your use of resources in GKE. Let's review three of them. The first one is all about cluster view cost optimization. In GKE, we have a cluster level cost optimization tab built into the console, rich with information that may be cumbersome to gather on your own otherwise. And that is shown in the first image on your screen. Once you navigate to this tab, you are greeted with a time series visualization, which is quite easy to interpret. For GKE standard cluster, this visualization is a time series representation that shows three key dimensions for CPU and memory across all of your cluster in a project as shown in the second image. So those three dimensions are total CPU and memory allocatable, so which is basically number of CPUs or gigabyte of memory that can be allocated to user workloads. Then we have CPU slash memory request, which means number of CPU or gigabyte of memory that has been requested by user workloads. Thirdly, we have CPU and memory usage, which is the actual usage by number of CPUs or gigabyte of memory by user workloads. Analyzing these in relationship to one another can help identify answers to important optimization questions such as, do we have too much allocatable CPU and memory idle across our GKE standard clusters? If so, can we do things like re-evaluating the machine types we use in a node pool? This can also help us bin back the cluster by having a higher percentage of allocatable resources allocated to the pod requests. Another thing that you can answer from by just looking at these three dimensions on this tab is that our workloads running in our GKE standard cluster requesting too much CPU and memory that goes unused. If that is the case, then we can do things like work with workload owners to adjust requests. This can also help us workload right size by setting requests to more closely reflect expected usage. For a cluster administrator, this information can be sort of a trigger to take action such as diving into individual clusters or meeting with workload teams to work through the requests and limits that's set for workloads. Okay, next thing in terms of GKE cluster optimization is GKE cost allocation. GKE cost allocation is a native GKE feature that integrates workload usage with cloud billing and its reports, allowing you to see and alert on billing not only on a per cluster level, but on a per Kubernetes namespace or per Kubernetes label level. It must be enabled on your cluster first in order for it to function, and then you can do that easily from your G Cloud. Without GKE cost allocation, the financial impact of a cluster and all of the different workload it might run were a bit obfuscated prior to this. With the cluster as the deepest level of detail in billing, finding areas to optimize or even performing show back and charge back was a challenge. Because cloud billing data has all GCP services, we can now filter and query across namespaces and their corresponding backing services, as you can see on this photo. Cool. Thirdly, we have workload view cost optimization. Once you have team identified that you may want to work with, GKE provides a cost optimization tab at the workload level, where you can then begin to drill down and identify specific workloads that could be optimized through an exercise called workload right sizing as shown on this image. This is the act of making sure that the pod requests more closely reflect their expected usage. As you can see here, we are given bar charts to represent the relationship of usage, requests, and limits to one another. And if you go About the color scheme, dark green is our CPU memory usage, light green is CPU memory requests, gray is CPU memory limits, and yellow is scenarios in which CPU/memory usage exceeds request. So focus on yellow. With this information, it becomes easier to quickly identify workloads that need requests and limits tuned for either cost optimization or stability and reliability. Well, GKE provides tooling to make optimization journey and process easier with the right data and insights at your fingertips. I hope this was useful. If you have any comments or feedback, please put them in the comments. Thanks.